Like this, little britches. All you gotta do is look for the bare necessities, the simple bare necessities. Forget about your worries and your strife. I mean the bare necessities are Mother Nature's recipes that bring the bare necessities of life.
And the bare necessities in statistics is the idea of a normal distribution. So let's look at our objectives. So we are going to use the 68, 99, 99.7 rule to estimate the area under a curve given a normal distribution. We are going to use a table to find the proportion of the z-score. We're going to use the table to find the z-score. And let's jump into it. Turn to your notes, page 8, please. So as we look for the bare necessities when it comes to the normal distribution, before we do that, we've got to figure out, well, what exactly is a normal distribution? What is a normal curve? Well, this is what a normal curve looks like. We have the symmetry going on, and the mean is always going to be the halfway point. What is a normal distribution? Well, as you can see here, we have to use this curve to establish a normal distribution. Here what we're looking at is the mean and the standard deviation, but look, I've got some Greek for you. As I look at this, here, this is for the population, and the mu, and here the sigma for the population. Whenever we use x bars for the sample. And we've got to also remember that any distributions, a normal distribution is going to be any distributions or observation that appears like a bell curve. And the reality is, I should say, it looks like approximately one, because in the real population, it doesn't happen. As I continue to look at why normal distributions are important, why are they necessities? Okay, when we have a good distribution of real data, and the reason it has to be a good distribution is because you have high points and low points. You have what you guys have heard about before, the idea of a bell curve. Okay, it's also a good approximation to a chance outcome, which means, did it happen by chance, or is there some legitimacy behind it? And then the third one, and for us in this class, this is the most important aspect. If you don't get a grip on the normal distribution and the z-score, which I know you will, you're going to have problems for the rest of the semester, because here we use this in many statistical inferences. Remember, the whole premise of inferences when we do hypothesis tests. So we want to see if group A has if there's a weight loss medication and group A lost 15 pounds less than group B, our question is that statistically significant? Well, in my head, heck yeah, that's significant, but it's statistically significant, and that's the whole premise of inference once we get there in the second semester. Now, here, the idea of the 68, 95, 99.7 rule. It is also referred to as the empirical rule, and as I look at the empirical rule, per our blue sheets that I've shown you before, please remember here we're talking about the middle 68%, the middle 95%, and the middle 99.7 for 1, 2, and 3 standard deviations within the mean. And this is exactly what I was saying. The mean plus or minus 1 standard deviation. The mean plus or minus 2 standard deviations. The mean plus or minus 3 standard deviations. So that gives us 68, 95, 99.7% of the data coming from the center. But also notice how I represented it over here. This is the same as, remember, saying the population mean plus or minus 1 standard deviation. population mean plus minus 2 standard deviations. So sticking with the 68%, 95%, 99.7. Now, with this particular question on problem number 5, this was data that I gathered from you guys at the beginning of the school year. I put it in stat key so that I could find the mean and the standard deviation, which takes me to this notation. Tried to squeeze it in there, no bueno. Okay, whenever you see something like this, what this is representing is N is telling you, okay, it's a normal distribution. Your thoughts are, well, why is that necessary? Because as we move farther on into statistics, we have binomial, we have a lot of other type of probabilities. So N is telling you that it's approximately normal. And here, that represents the mean, and that represents the standard deviation. And yes, it does have to be in that order. Our sample size that I have for this data was 83. So here, you notice that I put the mean right there in the middle. And as I answer this question, we want 1, 2, and 3 standard deviations away from the mean. So I'm going to do the math. Here I've got the mean plus 7.015, the mean minus 7.015. And right here, you got your math, guys. But let's also put it up here on our bell curve. So you will notice right now that within 1 standard deviation of the mean, this is represented right here in yellow, and yes, I did a little rounding because of space. So 56.3 represents 1 standard deviation below the mean. The 70.3 represents 1 standard deviation above the mean. Let's continue. Now let's find 2 standard deviations from the mean or within the mean. Both of those terminology is correct. And I'm going to cover this up. Actually, here, go ahead, write it down, plug it into the calculator, and then after you've plugged it into the calculator, let's mark it up here. So you can see the math, and yes, I've labeled here in the blue. That's 2 standard deviations. This is 2 standard deviations below the mean, the 49.3, and the 77.3 represents 2 standard deviations above the mean. And then finally, here, I want you to find the 3 standard deviations, but I'm hiding it. I want you to do it yourself. Okay, so go ahead and check yourself. And can't forget to put them up there. So let's remember what this is saying. The value of 42.2 is 3 standard deviations below. And the value right here is 3 standard deviations above. Remember, the mean is 0. So this is your plus 1, your plus 2, your plus 3, your minus 1, your minus 2, your minus 3. Okay, so let's look at problem number 9. And what are they asking me for? They're asking us to estimate the mean and the standard deviation. So basically at the top of that peak, go down, and then from there, see how many units there are from where you hit that horizontal. So you can see here, yes, I know when I traced it so it's visual, it's totally drunk looking, but hey, what can I say? Okay, so here, this looks like that's approximately the median. I could see you seeing 9.52. Okay, and here, they want the number of the standard deviation. Well, remember, it's not just from there to there. This is the middle 68%. So the middle 68% is 1 standard deviation away from the mean. So just like we did today in class, that means here you can see that it's going to be approximately 2 standard deviations away. Now, as we look at the 6899.7 rule, I want to show you something that you're going to have to write down. And you can see these values here. Now, before you say anything, are you going to have to memorize these? Oh, heck no. you are going to have to be able to cut it into pieces without memorizing it though. So go ahead and take a minute to do that. Now, let me just tell you briefly how this came about. Of course, if this is one standard deviation away, which is based on what I have right here, one standard deviation within the mean, well, this is your 68% right there. So if that's your 68%, and this is a line of symmetry that cuts it in half of 68 is what? Yep, it's 34. So you know that that's 34 on both sides. Okay, next. Now let's look at two standard deviations within the mean. As I look at that, that is the middle 95%. And as I look at the middle 95%, well, that means that this half is 45 and this half right here is 45. So if this middle area is 68, that means that these pieces are 95 minus 68, and then whatever that value is, that's got to be divided by 2. And you might need to rewind that. But think about it. If this whole thing is 68, if this whole thing is 95, and this is 68 of it, well, that means 95 minus 68. But then, where is it cut? It's cut into 2 places. So I whited it out so I can show you that the leftover from the 68 is 27, and then I have to take 27 and divide by 2 to figure out what's going on here and here. Because what is 13.5 double? Oh yeah, it is 27. If you're having trouble with that, no worries, because honestly, the calculator is going to do the work for us the majority of the time. Now, I know you heard me say the majority of the time. Other times, we're still not going to have to break it down like that unless you choose to. Now, I want to look at this next problem, the IQ test. And as we look at this IQ test, I need you to change your values. And the reason those are necessary is because we're not going to be able to use the 68, 99, 95, 99.7 rule using those values. So please wipe those out. Here, as I look at these problems, I am going to find the values that go with this mean of 110 and standard deviation of 25. And here are the values, and this is how I came up with them. Because remember, one standard deviation away is the mean plus the 25, the mean minus the 25. 2 standard deviations above the mean is the mean plus 2 times 25. 2 standard deviations below is 110 minus 2 times 25, and so forth and so on. So you see where I have the values. So now when I'm asking you what percent what is the percentile of the 160? The 160 is going to be right here. And if this is going to be from this tail to this point is 50%, and from here to here is half of 95%, so that's 47.5. To go from here to here, that is going to give me 97.5%. And that's another thing you might need to rewind. So I took this, then I took that, got those values and added them up together because they set the percentile, so the percentile is just going to be that value right there. Next, I'm about to look at this one. So now I'm looking at from 135 to 160. So that is the region that I'm looking for. So if this from here to here is 47.5%, and this region right here is half of 68, which is 0.34, and I should put the point there, not there. Do the math, find out what the leftover is. And you might need to rewind that also. Okay, so let me show this again using my beautiful tablet. If this right here, if this entire region is half of 95, that is terrible. That's where that 47.5 came from. And if this right here, going from here to here, is half of the 68, which gives you the 34, that means what are you going to be doing? You're going to be subtracting the 0.475 minus the 0.34 to get this region that's right in here to be 0.135. And now, as I look at part C, and they're saying to find the top 2%, all I can do is say find the approximate value, at least with this method right here. Well, as we look up here, don't we see that? So I was on freeze for a minute. Okay, so like I was saying, we are looking for the top 2%, and all we can do is approximate. Because if you look up here, any value that is above, this is the leftover point, well, the leftover 2.35%. So that means the score for part C is going to be approximately anything above, I was about to mark the wrong thing, anything that is above this right here will give me a little bit more than 2%. But all I can do is approximate, because the reality is precision is going to come with the z-score formula. Okay, so right here, the answer to C is going to be approximately, and that's all I'm going to do, approximately 160 when they ask you for what the score is for the top IQ. So you're going to have to rewind that a couple times, and if you have trouble with it, no worries, calculator is our friend. Now, I'm not looking at the homework right now, the blue homework assignment sheet, but I don't want you to do number 43, I want you to do it in class. And then problem number 7, we're going to do this together in class also, so that I can keep going. And as we look at this, I am looking at the idea of continuing with the idea of a normal distribution. There are certain things that I can say here that are very specific to a normal distribution. So when I say the word standard normal, when I say standard normal, that means, as you can see here, the mean is 0 and the standard deviation is 1. The problems that we just did a couple minutes ago, didn't we have a mean of 160, I think? I don't remember. That's so sad. We just finished it. But whenever you see the mean of 0 and the standard deviation of 1, this is referred to as the standard normal. Okay, notations. Showed you this kind of prematurely a couple of minutes ago. The generic notation is this right here, whereas remember mu is the mean and the sigma is the standard deviation. But when it's a standard normal, here you've got normal, and where the mean is always 0 and the standard deviation is 1. Again, that is when it is a standard normal.